like two sets of lines. There's the old ones and the new ones. I see the old ones in the morning. I'll probably like that. But then when the sun shines on them, you can see the new ones. And I just laugh at them.
All right, so hold on, Hayden. Don't let this stuff scare you. Let me go back to what we're doing. We got to find the right slide first. There we go. Okay. Now, so yesterday, we were doing one step mold gram with gram mold pens. So yesterday, you were either starting in grams, so grams went down and you were changing it to moles, and if you're starting in grams, you should be dividing by the molar mass from the periodic table. Some of you picked up on that real quick, but if you were starting in moles, then when you changed to grams, you would have been multiplying by that mass from the periodic table. It's more important to put the unit in the right spot first, because the unit tells you what's number. And yes, you did have to do a little bit extra because you had to calculate the masses from the periodic table. So, two numbers after the decimal, multiply them by how many of them is in the compound, and then add them all up. Now, I did give you the answers on yesterday's, and I also am giving you the answers on today's because it does help you. It lets you know immediately if you're doing it right or if you've done something wrong, and it does help build confidence when I do give you the answers like that. And I don't always do that. I am on today's, but I am not on tomorrow's. Friday is a work on these assignments day to make sure that everything is done and turned in. Yes.
Are we going to give us another video on too?
Tomorrow, not on Friday.
Okay.
No, because I'm just not giving you the, well, at least I haven't put the answers on the one that I'm giving you tomorrow, which looks a lot like the ones from yesterday. There's just no answers on the end. Yesterday's were all one-step conversions. Okay, and the way that I do a one-step conversion, I know I got into the opening yet. I personally use these keys. I do. All of them were one step. You're going from one thing into another. It is one jump. It is a one-step conversion factor. Today's, and I even showed you, I put my crosses on there. I showed you, and I put everything in guest format. It just gives you enough space to put everything in there. I show you if it's a one-step or if it's a two-step. No, it's just one extra, it's two one-steps put together. So the difference between a one-step and a two-step for me is a two-step. And I know you can't see this online, but I have them all in the notes. The two-step, you're going to start with something, change it into a mole or a particle, change it into something, and then you're going to end up having to be going atoms the other way around. Literally, this would be a one-step conversion. This would be a one-step conversion. This is where I'm smashing them together. Tomorrow, we're going to bring in 1, 2, and 3-step conversions because we're bringing the mass back tomorrow. So yesterday's paper was moles and grams, was periodic table. Today is not grams. Today is moles and particles. You only use that periodic table if there's grams involved. Today, we're using Avogadro's number. Do you guys remember what that number is? It's a really big number. So I didn't hear the power, but it's 6.02 times 10 to the 23rd. There are 3 particles that number would go with. What are the 3 little bits that we deal with in chemistry? 3 itty bitty bits we deal with in this class. So not as small as protons and neutrons. A little bigger than that. Okay, so those are elements. What's the smallest? What is the smallest part of an element that still has its properties? What do we call these things? Oh gosh, all atoms. Atoms. The smallest particle of an element is called an atom. So that's one of the 3 particles. Now we have 2 types of compounds. We have ionic compounds, and we have covalent compounds or molecular compounds. What are those particles called? They're different. So a molecule, or if it's ionic, it's called well, you can abbreviate it, formula unit. So their Avogadro's number is 6.02 times 10 to the 23rd. Do not forget that that mole tune, which I am taking as a test grade, is due Friday. You should have already told me what you wanted to do. If I didn't quite understand, I probably sent you a message back. So 6.02 times 10 to the 23rd representative particles, of which could be an atom if it's an element, could be a molecule if it's covalent or molecular, it could be a formula unit if it's ionic. Now, there was a couple of issues I had with my fourth period, so I fixed them. Besides, my recording was, I sounded like a robot. And now, if I go on there, like if you're remote and I sound all garbled and robotic, please unmute yourself and tell me. All I have to do is reload the Google Meet. It happens every now and then. But I can't hear myself. I can't hear myself, and I can hear myself as I'm talking, but I can't hear like the recording until I stop it. All right, so you guys have almost all of this. In fact, I think you have this entire slide because I want to explain what this means. First of all, 1 mole of any substance has Avogadro's number worth of representative particles. If that particle is an element, okay, that thing is called an atom. It's everything that's here. An element's representative particle is an atom. That does not include those 7 diatomic elements because those have 2 and they're all nonmetals. So I2, Br2, Cl2, F2, O2, N2, and H2, they're representative particle because those are molecular compounds. Those are molecules which are made up of atoms, and in that case, there's 2. If I tell you carbon dioxide, I know there's 3 atoms in carbon dioxide, but a mole of carbon dioxide is not that many atoms, it's that many molecules, of which each molecule has 3 atoms in it, which is what makes it a 3-step or a 2-step problem. If you have an ionic compound like salt or aluminum phosphate or, I don't know, calcium carbonate, a mole of that thing is worth Avogadro's number worth of formula units, which we do abbreviate as FU. Okay, but that formula unit is made up of a certain number of atoms. If you're going directly from moles to atoms and it's an element, it is a 1-step problem. If you're going from moles of either a covalent or ionic, you first have to go to its particle and then you can go to its atom. It just depends. And honestly, just to figure out how many of the atoms in a compound, you just have to count them up, which is what we literally started with that the very first, oh no, that was what, last Monday. The hardest part is to figure out how many steps you have. Now, I took that out of today's paper because I told you if it was a 1-step or a 2-step with the conversion process. I'm not going to do that to you on a test because I know full well Ms. Callan's not going to do that. She's the one that makes tests. If you're going from moles to particles, you're going to have a 1-step. This being elemental atom, ionic formula unit, or covalent molecule. If I say covalent molecular, it's the same thing. Only if you're going between, and this is not on yours, this is just an FYI, this is the way that these work. If you are going from moles to atoms, and it's an element, it's a 1-step. That would be like lithium, or lead, or carbon, but not those 7 diatomics. Because those are compounds, because they have a 2. So if you go from moles to atoms, and it's a compound, whether that be ionic or covalent, I don't care. That is a 2-step conversion problem. I just need to show you how to do that. One more on here. So a 2-step, now remember this can be reversed. You would go from moles to particles, and then particles to atoms. Or, if you flip it, you could go from atoms to particles, and then from particles to moles. But you're constantly diagonally linking these things together. And like I said, you will have another work day. I split these notes into two parts on purpose. I didn't want to jump from one-step conversions to three-step conversions without showing you two-step conversions in between. You just have to take a second. You have to look to see what you're starting with. And whatever you're starting with, what can you convert into? Look to see what you're trying to change it into, and what you're changing it into, what was the thing that could have been converted from, and see if they match. If they don't match, you need another conversion factor. Okay, on to work the problem. How many iron atoms are present in 2.5 moles of iron? First, we have to figure out what iron is. Is it an element or is it a compound? It's an element. So can you go directly between moles and atoms if it's an element? You just have to do the extra step if this would have been a particle, a compound, not an element. Elements are easiest, one step. So I can go directly from moles of iron to atoms of iron using Avogadro's number. What do you put here to start off with? 2.5 moles of Fe. I know it's not a big abbreviation, but we do abbreviate the mole as MOL. Do not leave off the unit, including, in this case, the element iron. You will get confused, yes.
I think this is 24,
Let's see. That was more of an explanation. Oh, you have to count them up. So like, let me show it to you. Okay, so like, so 1 Fu, let's do CaCO3.
So it's depending on
It
the.
depends on the formula. So I have 1, 2, 5. You just have to count them up. That's why I didn't put a. You have to be able to determine how many there are. All right, so I don't want to be in moles of iron, and it should be over 1. Good. Where are moles of iron going to go so that I can change out of it? Cross them down. And if I start with, and you can't see me pointing, I'm not sure who else is online. If you start in moles, can you directly change into atoms? Yes, using this conversion factor. Now, you have to go back and look at the conversion factor to figure out what number goes where. The mole of iron. What number is attached to the mole? 1. And what number is attached to the atom? Avogadro's number. Here comes the part that's going to take most of the time. If you tend to use your phone as your calculator, you need to pull your phone out and open up the phone app. I know, depending on if you're using the regular phone, now if you're using your Chromebook, open up your calculator from your Chromebook. If you do not know this handy little trick, I'm going to figure out where my calculator is. There it is. If you simply do this, you get a scientific calculator. Regular Droids and iPhones will do this. I am not sure how your Chromebook is doing this, but if you're going to be using your calculator from your phone, pull out your phone and get into your phone app. Please. Because if you don't know how to use a calculator, I don't care how well you set that up. This is going to tell you what you tell it to do. It does not understand what you're thinking. It understands the buttons that you push. So to put this in the calculator, you're going to push 2.5 times 6.02. Now, we don't use times 10 in the caret in science because it messes up the calculator. See where it says EE somewhere. EE, capital E, not lowercase. Press that EE, and you're going to put the number 23. And you're going to hit enter. Then you should see this. I need to know if you are not getting 1.505 E24. You're not getting it.
What? I'm going to say since you're telling me it's 2.5.
The answer's to that, which is why it's right. You not getting this?
No, I just missed that. So,
Okay, so you're gonna do, you're not gonna do, you're looking for my part, so you're gonna throw it out, you're gonna do 2.5, okay, and you're gonna do times 6.02. And you don't do times E, you don't do E times, but you're gonna push this EE, and then you're gonna push 23, and you're gonna hit it. Okay, is there anybody else that is not getting this? Well, these aren't gonna help you, you've got to have these. Everybody's getting it. Okay, now the reason why I rounded it is because my starting substance, let me know, Hayden, if you're not getting this too, or anybody else that's online that I haven't seen. My beginning substance has 2 numbers in it. I don't care about that. That doesn't count. That's a conversion factor. Just like the numbers from the periodic table don't control your answer. So since 2.5 has 2 numbers in it, 1.5, the 0 is not going to affect the 5, so it rounds to 1.5 times 10 to the 24th atoms of iron. You are more than welcome to write a capital E instead of times 10 to the 24th. I do. I know you're not used to doing it, but that's what it means. Okay, before I move on to the next one, this is the easy one. Are there any questions calculator related or not? Yes.
I don't know how you did it.
Did you get that in the calculator first of all when I told you to push your button? Okay, so that's the first part. So do you understand why my starting substance goes in the top left-hand block?
Yeah.
So this is your starting gate, over 1. I don't want to be in moles of iron, okay? And so this is a giant division line, first of all. This just separates multiplication from side to side. So when I bring down moles of iron, they're going to cancel out. They're not going to be there anymore because anything divided by itself is gone. Starting in moles, I can directly change of atoms where 1 mole of iron equals 6.02 E23 atoms of iron. It's like saying 1 foot is 12 inches. Aren't they? Don't they mean the same? Like they're the same length. Well, 1 mole of iron is 6.02 times 10 to the 23rd atoms. They're equal. Which is why I can flip them around, because anything divided by itself is 1, which does not affect the problem. Because that's how tiny an atom is. It takes 602.
Every atom, not just iron.
Every atom, if it's an element, it's that many atoms of copper, it's that many atoms of sulfur, it's that many atoms of lithium. But if you have a compound, then it makes it a 2-step, which I haven't shown you how to do.
So we're not including the like stuff we see on the periodic table.
No, that is for grams. The stuff we did yesterday,
Yeah.
that is grams only. It's a matter of, no, it's what is your unit and what is necessary to convert. And you have to be able to calculate the mass using a periodic table because every compound is unique. With Avogadro's number, it's can you go directly between moles and atoms, or do you have to start part way at a compound and then go to the mass? Is there another question over here?
yeah. So when we were talking about the calculator, where did you get 23?
To the 23rd power.
Oh, okay.
That E does times 10 in the caret for you. So it's 6.02, the EE button, then the power. Whether it be positive or negative, the power. Let's go on to the next one. We gotta build this first. Aluminum, Al plus 3, phosphate, PO4 negative 2. You need to crisscross them first. I probably really should take attendance right now. Where the 3 is going to go to the phosphate and the 2 is, excuse me, the 2 is going to go to the aluminum. Okay, so I see Hayden and Tucker. Those of you that are online, if you do have a question, just unmute yourself and ask, because we do this kind of stuff the rest of the year in some way, shape, or form. I'm trying to go as slow as possible and teach you how to do this one step at a time. Yeah, I see Tucker, I see Marisol, and I see Hayden. Hayden. Where's Hayden? Okay, let me go back to here. Right. So I've successfully built my compounds. So this doesn't mention grams at all. So I'm not going to have to do what I did yesterday. But it's mentioning atoms. Okay, so I know I'm going to be using Avogadro's number somewhere. But the problem is, this is not an element. This is an ionic compound. So I can't go from moles to atoms. What I can do is go from moles to particles, which are formula units, which you are welcome to abbreviate it as capital F, capital U. We all do it. But to get from one of these to atoms, you have to count them all up. 2 aluminum, 3 more phosphorus, and 12 more oxygen comes out to be 17 total atoms. All I did was distribute the 3 to what was inside and then add them all up. I don't have to look at grams to this. Grams are not mentioned in this in any way, shape, or form. Now, they will be tomorrow, and I will show you how to do 3-step conversions. Just honestly, it's a matter of taking your time and seeing what you're starting with, what you can change it into, seeing what you're ending with, what that can be changed into, and trying to link them up together. I promise you, once the process clicks, you will not have a problem with stoichiometry. You just have to learn the new link. So, what am I starting with in that problem? 3.7 moles of, and this is the formula for aluminum phosphate. I'm going to put it over 1. I personally don't put anything in that first bottom block, but I've learned that for some reason that confuses you. So just put it over 1. I don't want to be in moles of aluminum phosphate, so I'm going to bring that down. And I'm going to look at my 2 conversion factors. And I'm going to find the moles of aluminum phosphate, which is right here. And the only thing I can change it into is formula units. I don't have a choice. That's the next step. It's the next thing I can change it into. Now, I don't want to be in formula units, so I'm going to drop that down. And once I'm in formula units, can I get to atoms? Yes. Now I'm going to come back and I'm going to fill in where things belong. Yes.
So, on the paper, you don't get you show us that you don't have the compound for the aluminum phosphate. So, on a test, will there be questions with it outside, or will we have that sheet of paper?
The polysulfone chart? I'm not going to make you memorize those at this point. Well, I'm either going to pull out the ones that I photocopied before, or there'll be a link in Canvas if you end up being remote. Honestly, I mean, there's some that, because I use them all the time, I memorize them, but others, I still look them up. I mean, they're not as common. Things like oxalate. Hardly ever use oxalate. Or dichromate. Hardly ever use dichromate. I know it's Cr2O7 -2, but you hardly ever use it. Now, to figure out this one, I am looking at how to go between moles and formula units, which is this guy. And the mole is going to get a 1. Right now, the mole's always seeming to get a 1. And then the formula unit is getting Avogadro's number. You are welcome to write an E instead of constant. Okay, so that conversion factor is gone. Now, the bottom conversion factor tells us how to go between formula units and atoms, which, if I don't highlight this, it's one of the reasons why I got this remote. For those of you that are remote, like, ha ha ha. Anyways, those of you that are remote, you can actually see me instead of just pointing. So the formula unit now gets a 1, and then the atom gets 17. And the way I knew it was 17 was I just added up how many atoms through an aluminum phosphate. So I know I can cancel out moles of aluminum phosphate. I can cancel out formula units of aluminum phosphate. You do not need to multiply or divide by 1, and this becomes a pure multiplication problem. So we're going to make sure we can put this in the calculator. Come on, phone, wake up. All right, so I'm going to clear it out and get my scientific calculator. 3.7 times 6.02 EE 23 times 17. Hit enter. And my calculator says 3.78658 E25. Okay, I don't want that many numbers in the coefficient. How many do I want? I want 2 of them. So this big old honking number rounds to 3.8 times 10, or E, 25 atoms. Total atoms. Not specifically oxygen atoms or phosphorus atoms, but total atoms present in the sample. Sometimes we ask for a specific element in the compound for atoms. You just have to take your time and just really pay attention to what it's telling you that you're trying to solve for. I literally took 2 one-step problems, and by using a formula unit as a link, smushed them into a 2-step problem. I know you're still writing stuff down. Are there questions on this one, or where I got stuff from, or possibly calculator issues? Yes.
You don't do your times E?
No, you don't do times E. If you're using the E function, it is coefficient E tower. Whether it be positive or negative. Right now, they've all been positive. If you do times E, it moves the decimal and does weird stuff. I'm just telling you, if you try to resort to doing times 10 in the caret and you don't know how to use parentheses, it's going to do what you tell it to literally and not what you're thinking in your head. And this EE function removes a lot of those extra parentheses. One more. We have 4.5 E22 atoms of oxygen in a sample of carbon dioxide. How many moles of carbon dioxide must be present? Okay, so oxygen atoms, but in a compound. So I can't go from atoms to moles. I have to go from the atoms of oxygen to the molecule of carbon dioxide. Once I'm in a molecule of carbon dioxide, I can go to moles of carbon dioxide, which is why this is a 2-step problem. I have no idea how nice they're going to be on the test or on the 6 weeks test, the CDA. I don't know if they're going to give you a formula first or if they're going to ask you to be able to make a formula from a word. I really don't. But carbon has 1, di, 2, oxygen. So the formula for carbon dioxide is CO2. 1 mole of carbon dioxide gas has Avogadro's number worth of particles, which are molecules. And in 1 molecule of carbon dioxide gas, oxygen, there's 2 of them. Now I'm starting with oxygen atoms. Over 1. I don't want to be in oxygen atoms, so I'm going to drop it. You're going to learn, I don't care what the heck this unit is, drop it by reflex. Then look at the possible conversion factors that you could use and find where the atom is. But you can't see me pointing. The atom is here. It's going to get a what? A 2. And when I change it to the particle, it's going to get a what? A 1. I come back and do numbers at the very end. But they're attached to your units. I don't want to be in molecules of carbon dioxide. I want to be in moles of carbon dioxide. And once I'm in molecules, but you can abbreviate molecules, M-O-L-E-C. Do not abbreviate it as mole. Not the same thing. Not the same thing at all. But once I'm in a particle, in this case a molecule, then I can change it to moles, of which the mole would get a 1 and the molecule will get Avogadro's number. This is where you have to understand how to use parentheses with the calculator. If you don't, when you hit divided by without parentheses, it will divide the numerator by the first value, which you would probably put in a 2. It's going to store that answer into a calculator brain, and then when you do times Avogadro's, it's going to multiply that answer by Avogadro instead of dividing by Avogadro. So I'm going to clean it up. More oxygen atoms, and more molecules of carbon dioxide. You do not need to multiply or divide by 1. All I did was got rid of all the fluff. Really what I'm left with is 4.5 E22 moles of carbon dioxide, all divided by 2 times Avogadro's number in the denominator. You have 2 options to do ones that have both top and bottom. You can either multiply out the entire top, which is just that number. You can multiply out the entire denominator, and then you can get those answers and do top divided by bottom. Okay? Or you can let the calculator do everything for you in one step by using parentheses. So to put this one in the calculator, this is where I actually wish I had an old school Elmo. I don't think you can even find them anymore. So it's like a data projector, like onto a screen. Like everything, you can see the person writing, and it puts it up on a screen. Old technology, but in this case, it would be nice. So you're going to push 4.5 E22. I'm not times anything else. Divided by. Here's where you have to open parentheses. 2 times 6.02 E23, close parentheses, and hit enter. You should get a really long chain of numbers after decimal, of which I'm only going to want to keep 2. Zeros in the front do not count. It's 0.0373. The 3 is not enough to round to 7. So this is how many moles of carbon dioxide you have. Now this is where I'm probably going to have people that you're not getting the right answer. And that thing has been making some weird popping noises. See if you can get this in the calculator. If not, I need to figure out what the problem is. And this includes those of you that are online, remote too. But you're probably going to have to turn on your screen and then turn your calculator around and let me watch you punch things into the screen. I know most of us keep the camera off, including me, because it's weird. I don't like seeing myself when I'm presenting. It's just bizarre.
No,
Did you get it?
I didn't get it. Yeah.
You can still do 2 times Avogadro and then do whatever that is. Divide that into 4.5. It's just the more times you can enter in a calculator, the more often you're going to have a chance to put an error. You put a wrong button.
I usually do.
So, but there's nothing wrong with doing that. There's really not. Let me double check them online really fast. Let me do a quick little take it. On today's paper, once again, I tell you, and I know I'm starting to give you guys a lot of stuff. Unfortunately, with stoichiometry, I have to make you work the problems. The more you work them, especially if I give you answers, the more confident and comfortable you get, the easier this does become. I know some of you right now are like, holy crap, I need to quit this class. But this is real chemistry. Starting with balancing equations, which a lot of you did okay. That's real chemistry. All the other stuff you've done up to this point is 9th grade IPC. And most of you didn't have it, did you? So you don't have that foundation. But we are doing math the rest of this year. And a lot of it is a conversion. I'm sorry, that is what chemistry is. It is chemical math. So don't worry about the guess stuff. If you want to identify what you're starting with and what you're changing it into, it gives you room to write your conversion factors out off on the side. This is to show your work. One line is a one step.
Excuse this interruption. Students that plan on going to after-school tutoring or detention with Mrs. Carr, it will not take place today, so please make sure that you notify your person that's picking you up or make your way out to the bus.
Who's out in,
Again, Mrs. Carr will not have after-school tutoring.
I'm going to stop the recording.
Today. Thank you.
One of these days, something's going to come out of my mouth that shouldn't come out of my mouth. I'm going to